Hello everyone, Mr. Fawcett here, and we are back for another geometry lesson. Today we're going to focus on angles. So we're going to start off by just going over what the different parts of an angle are. Then we're going to talk about the different types of angles based on what their measurements are. And finally we'll get into some algebraic problems where we've got to solve some equations based on different angle measurements. So to get us started though, let's do two review questions. Pause the video again before you watch me go through any problems. I always want you to attempt them on your own. So try numbers 1 and 2 and then come back and see how you did. Okay, so number 1 says draw ray AB and ray AC where A, B, and C are non-collinear. So they cannot lie on the same line. So, all right, let's see. And notice that the way the letters are written matters. So A is going to be the end point of the ray, and B is going to be another point on the ray. Now, I have to draw another ray AC, and I just have to make sure that they are not, all 3 points are not in the same line. So the only place I can't draw AC is right here, because then they would all be on the same line. So I just need to create a little angle. Now, here's another ray, AC, and the 3 points are non-collinear. Okay, number 2, we have a quadratic equation we need to solve. Whenever we see a quadratic equation, factoring is going to be the method we choose to use first. Again, you're always free to use the quadratic formula if you have access to a graphing calculator, but this concept of factoring is something you're going to carry with you into Algebra 2, into pre-calculus, and into calculus if you get there. So it's a skill we want to practice working on. So that's why I'm continuing to give you problems every now and then where you need to use factoring. So I'm going to get all the terms on one side, set the equation equal to 0. So I'm going to subtract 84 from both sides. And now I'm going to make my factor sum chart. Remember, I'm going to end up factoring the trinomial into something that looks like this, but I need to figure out what goes inside the factors. So my factor sum chart, I am looking for factors of negative 84 that sum to negative 17. So 84 is, a fairly large number to find factors of, but you can break it down. Sometimes what I like to do is just think of the small numbers and think about what you need to multiply those by. So for instance, 2. If I multiply negative 2 by 42, I get negative 84. That's going to sum to positive 40. You could think about 4, okay, or you could think about 3, but well, actually 3 does go into 84. So if I did negative 3, then I would need 28, which would give me 25. Then I could think about negative 4. Well, if I divide negative 8 by negative 4, I get positive 21, which gives me positive 17. Now this is close, right? But I need negative 17. So let me just flip the sign of these factors. This will give me negative 17. So 4 and negative 21, those are my two factors. So x plus 4 times a quantity x minus 21. I then have my two individual equations to solve using the zero product property. And I get x is equal to positive 21 and x is equal to negative 4. Okay, so just a little review on using factoring to solve a quadratic. Okay, let's start talking about some angles. Again, we're going to start with the very basic building blocks of angles. An angle is formed by two rays or sides that share a common point. So two rays. That point is going to be called the vertex. So if I draw you an example down here, This vertex is where the two rays meet. It's where their endpoints are. It's going to be an important part of the angle to identify. And then you have your two sides of the angle. The exterior, we'll go with the interior first. The interior of the angle is the set of all points inside of the two rays / sides when extended indefinitely. So all this area right here, and again, these are rays, so they technically keep going. So all this area would be the interior. All the other area, all this area on the outside of the angle, that would be the exterior. So we've labeled the angle, we've labeled the vertex, the interior, and the exterior. Okay, let's move on to the next page. Okay, so one of the biggest things you need to walk away from today with is knowing how to name angles. So there's three ways you can do it. You can name the angle using 3 points. Okay, so when you do this, you always want to put the vertex in the middle of your 3 points. So let me give you an example. Actually, we're going to use this example number 1. So if this is our angle, and I want to name it using 3 points, I'm going to put a little angle symbol, and I can say E, K, G, or I could say G, K, G, K, E. But you must have the K in the center because that is the vertex. You can also name an angle using only the vertex. This is only correct if there's only one angle in your diagram with that vertex. So I could also just say here angle K. And lastly, they may give you a little number inside of the angle. You can also use that. So you could just say angle 2. So those are 3 different ways of naming an angle. All are correct. Sometimes you may only have the option of using one of these ways because they only provide you with enough information to use one method over another. What I want you guys to do is I want you to look at number 2, and I'm going to trace an angle, and that's the angle you all are going to try to name in as many different ways possible. So I want you to name this angle right here in as many different ways as you can. Okay, so hopefully pause the video, take some time to do that, and then come back. Okay, hopefully you've wrote down several different ways. First way, I could say angle S, Y, H. I could also say angle H, Y, S. Let's think about, could I say angle Y? Would that be correct? Would that not be correct? If you have that on your paper, think about what your reasoning would be for being able to use that. So here's the problem with just saying angle Y. If I say angle Y, how do you know if I'm talking about the pink angle or if I'm talking about this blue angle? Or maybe I'm talking about this green angle right here. And of course, there's some other angles as well. So this goes back up to number 2. And that's why I put this statement in parentheses. You can only use the vertex if there's only one angle present with that vertex. So over here, we only had one angle with vertex K. Over here, we have many different angles with vertex Y, so it's an unacceptable method for naming one of the angles. So this is no good. These 2 ways right here are the only correct ways of naming that pink angle. There is no number given, so we can't use the third option either. Okay, so that's naming angles. You'll get some more practice with that either in this video or the part 2 to this lesson. We're now going to talk about some of the different categories of angles. So I think I said there's 4 main categories. I'm actually going to give you 5. And these are the ones that you're going to need to place angles into based on what their measurements are. So an acute angle. This is an angle whose measurement is less than 90 degrees. And for this course, we're only going to talk about positive angle measurements. So an acute angle, when I say less than 90, I mean greater than 0 but less than 90. So its measurement is less than 90 degrees. And an example would be if I had an angle and its measurement was, we'll say, 33 degrees. An obtuse angle. These have angle measurements that are greater than 90 but less than 180. So greater than 90 and less than 180 degrees. An example of this would be if we had an angle with a measurement of 120 degrees. Okay, a right angle. This one measures exactly 90 degrees. Okay, and you may see this 2 ways. The most common way is that you'll see a little box. We've probably seen that from a middle school geometry section of a math course. But you can either see the box, or you could also see it with a 90-degree measurement here. It's just far more common. Almost any time you see a diagram which has a 90-degree angle, it will have the box rather than saying 90 degrees. Okay, let's move on to, I believe we have straight angles next. Okay, so straight angles measure exactly 180 degrees. And if you're wondering what this angle looks like, well, 180 degrees is just a line. All right, so these angles just look like lines. They're 180 degrees. Reflex angles. These angles measure more than 180 degrees, but less than 360. So greater than 180 degrees and less than 360. And these might look something like this. Now you think I may have just drawn an acute angle or a right angle, but the reflex angle is this angle behind it. We're on the other side. And we could just say 270 would be the measure of a reflex angle. So these are strict categories of angles based solely on whatever the measurements are. So if you know what the measurement is, you can place it into one of these categories. And let's actually do some of this. So down below, we have a bunch of different angles. We're going to skip the how to measure an angle using a protractor. That's something we'll save if we have an in-class session. So here are the angles here. Now, these are drawn to scale. So you have 4 angles. They are drawn to scale. So if it looks like it's less than 90, it is less than 90. You can make that assumption. If it looks like it's a right angle, it is a right angle. You can make that assumption. You're going to just put these 4 angles into whatever category they fall into. Okay? You don't have to measure them. You're just going to put them into a category. So pause the video, do that, and then see how you did. Okay, so the first angle would be known as an acute angle because this measurement is less than 90. For number 2, we have an obtuse angle because this measurement is greater than 90 but less than 180. And you can kind of make a judgment call here, right? You know that the right angle would be something like this, right? So this angle is clearly larger than a right angle, but it's also not quite a line, right? So it's got to be obtuse. All right, number 3, they give us the little box, so we know that this is a right angle. And for number 4, they show us that they're talking about this angle right here, which is more than 180 degrees and less than 360. So this is what we call a reflex angle. Okay, now that we have our categories of angles down, let's look at, we'll finish this with these right here. Let me make the screen a bit smaller for us. So we're just going to finish off with how to write congruent angles. This is very similar to how we write congruent segments. So congruent angles, just like segments, you can show that they're congruent using tick mark, or in this case, arcs, right? So we have one arc right here and one arc right here. That means that angle Q and angle J are congruent. They have the same measurement. So if one was 30 degrees, the other one would be 30 degrees. Same thing with this angle right here, angle R, 2 arcs, so it is the same measurement or congruent to angle K, and same thing with P. These arcs are already in red. So P and L are congruent. So we're going to do the angles. We're going to do the angles first. All we would say is angle Q congruent to angle J. And you can go ahead and fill in the rest of these. You're allowed to use only one letter because there's only one angle at each vertex. So you don't have to use 3 letters if you don't want to. Then go ahead and write the congruency statements for the sides over here as well based on the number of tick marks. Okay, so second set of angles, angle P congruent to angle L, and we have angle R congruent to angle K. Moving on to sides, I have side PQ with 2 tick marks. So segment PQ congruent to segment JL. That also has 2 tick marks. Then I have segment PR with 1 tick mark congruent to segment KL. So segment PR congruent to segment KL. And to finish this off, QR has 3 tick marks, which means it is congruent to JK, which also has 3 tick marks. Okay. This may seem like a very basic skill, and it is, but it's going to become important when we get into our proofs later on in future units, where this stuff needs to just be kind of like the back of your hand. You need to know it. You don't really want to have to be thinking about it because you're going to need to save that brain power for the proof side of this, which is a little bit tougher. So let's get the fundamentals down. Let's get the foundation, the building blocks down now, so that as we move forward in the course, the future concepts come a little bit easier to us. We'll be back for part 2 of this video where we do some practice problems as well as look at the angle addition postulate. Until then, though, this is Mr. Fawcett. Enjoy the rest of your day.